it's finally time to get the long scale installed on the back of the lathe. So this is for the Z travel. This is a 60-inch scale, reads to 5 microns or 5 millimeters. So what we got to do first is get the scale. So I got it centered up on here, started assembling the bracket there. So what we have to do is put the scale into the mounting bracket, which is called a backup spar, S-P-A-R. And then what we'll do is actually connect the bracket for the reed head onto the bracket and then take it over to the machine. I've already taken the time to center the carriage on the lathe and then just put a Sharpie mark on the bed. So let's get this guy installed in here. It just kind of sits in a lip, and then you tighten a set screw on the top to kind of jam it in place. So the bottom of this thing is just kind of got a bevel on it that you fit down inside this channel. So for the longer scales, they include a mounting bracket like this. Not really necessary for the shorter scales, of course. So when we're all done, this guy, the scale itself will actually not be mounted on the bed of the lathe, just the mounting spar will be. And then, is this the right size? Doesn't seem like the right size. And then the backup spar will actually be what's hard mounted. That makes more sense. Okay. Get this guy centered. And the instructions tell you just to tighten the center one, so we're not going to leave it there for long. So yeah, and then what we want to do is take this bracket, which is basically, if you're standing behind the lathe, this is mounted to the back of the carriage, and then it drops down and meets up with the reed head. So obviously adjustment in both directions, so you can put it wherever you want. So we'll take these little guys, and screw on the reed head. Okay, and then I'll just put this guy down so it's not cantilevered against this so much. And I'm gonna leave you guys here while I move this over to the lathe, and then we will figure out our next steps on mounting spot. Been messing around a little bit, getting this thing figured out. And I think what we're gonna do is put the scale up against the planed section of the bed down here. And the kit came with some spacers. So ideally, you put these on and then you use these 2 set screws to level it. But unfortunately, these guys are too small because this is such a deep recess. I've got to make some spacers that are taller. And the reason for that is the bracket here that's meant to line everything up is just not long enough to to live with just that short spacer. What my plan is to mount right here about where this center screw is, that screw hole rather. That's where the Bijur oil pump is mounted. You can see the line right there. So that bar, that black bar down here will mount just below that screw hole, and then we'll make some spacers for the oil pump so it can still sit right there. But yeah, that should be pretty good. The other thing we need to know is how true is this surface compared to the bedways. So let's put an indicator on the carriage onto this surface and see what it looks like over the travel distance. All right, I'm out of travel, and from where I can see it, that's about 2,000 over that entire length. That's pretty incredible, actually. That part of the bed was just planed for, actually I don't know why. Obviously it makes it look a lot nicer, but I don't know why Monarch took the time to machine that. Found a piece of material that's about the right size. This cutter does not have the right inserts on it for aluminum, but you know, I'm gonna use what we got. Hopefully it doesn't make too messy of a finish. So we'll just clean up the top, bottom, and then both faces, and then we'll cut it into pieces. Not too bad, is it? Give myself a little backstop so these lines will be perpendicular to the back edge. And what I want to do is leave just a little bit of a gap. Basically the kerf of the blade and then because this has already been machined on 4 sides, we should be able to gang mill and put all of these together in the vise at once. And then when we machine them, they'll all be exactly the same. So let's go over to the roll-in and chop this up. Obviously, the best way to do that is to put them all in the saw with a stop, and that way they all end up the same length or the same width. So this could have been, definitely could have been better, but I think we will still survive even though they're not going to be real close. And hopefully this doesn't cause any problems having them ganged like this. So I've got the sides are all pushing up against each other. So there's going to be some air gaps underneath. And then we'll just go lightly across this until they're all exactly the same. Flip them over and then push them all down. And that should give us parallel sides when we're done. Okay, well, it's a mess, but the finish looks nice. Take these out, deburr them, flip them over, and then we'll have our finished thickness done. Being a little smarter and got my chip shield set up, so got a little bit of cleaning done and put our got our parts deburred and everything. So this guy has been centered up in this direction and in this direction, so we're right in the center of it. So what we're going to do is drill and then spot drill and then drill a through hole for clearance on those 1/4 20 screws. Yeah, that looks good. I'm not sure I really need them, but it's not going to take too long to go ahead and put them in there. So the original parts have a 1/4 20 threaded holes on here, so you can drive the adjusting set screws down and then kind of tweak this thing back and forth to get it perfectly true. So I'm going to go ahead and do that. Like I said, it shouldn't take too long. And our center line in X is the same. So all we need to do is move 1 inch in either direction to get our correct position. So I've got my parallel moved out away from where the hole is, and then it's just spaced with a couple of blocks out of my collection. And this guy should have plenty of clearance. I've got an adjustable parallel in here that's keeping pressure on these two parallels so that they stay evenly spaced, and we'll get a number 7 drill and go to town. think I've got it all figured out. So our spacers look like they're going to be pretty good. What we're going to do for alignment is a little bit different than what they call for, but I'm sure this is almost always the case where you've got to make adjustments to your install. So what they want you to do is center the scale on the center of the carriage at its center of travel along the bed. So if I were to do that, it would be right here. Unfortunately, that would put me kind of in a tough spot to get the reed head bracket mounted to the carriage. And so in order to make everything happy and line up right and give me plenty of travel in all directions, I'm going to shift it over to the left here towards the tailstock a bit. It's like 4 inches or so. And the reason for that is I will still have enough travel on the headstock end. I already checked and align my bracket to where I want it mounted on the back of the carriage. So that's just kind of the reality of it, having to make adjustments. I may learn that throughout this installation that was a bad idea, but from what I understand about these things, I think I'm in good shape as far as where the travel limits are and everything. So the next thing I need to do is take these guys off. I just taped them on with some double stick mounting tape and then remove the scale itself. And we'll line up our mark, the center of my mounting bracket or the backup spar, put it where it needs to go, and then put a transfer mark somewhere on the bed where the end of the scale, backup spar is, and then drill and tap for 1/4-20, and then we'll get it leveled, exactly where it needs to be, and do the opposite end, and then do the ones in the center. And then once all the holes are drilled, we can mount it with our mounting blocks, and any adjustment we need to do to get everything else trued up, we can use our little leveling jack screws that are in there. I think the easier way to do this is to line up my spacer block behind the mounting spar, and then line up my mark over here in the center. And then I can just use the mounting block for my transfer punch. Okay, that looks pretty good. Actually able to make some chips. That's nice. There's my little rig. I've got my big steady rest on the floor, the 1, 2, 3 block, and then a machinist jack holding up the other end. I'm not really sure how you're meant to do this by yourself without, some kind of rigging like that. But anyway, hopefully this is going to give us a result that's usable. All right, not too bad for just eyeballing it. Only about 14 thousandths off over, that's at least 3 feet. I'm just a teeny tiny bit low on this end, so bring this end down just a hair. Not sure I made it better there, did I? Oh, that's more like it. That is 1/1000th over about 4 inches. So that definitely qualifies as good enough. So in that position, we're going to go down to the other end and I'll transfer punch through the hole, through the spacer, and then we'll drill and tap our next hole. Most of my work is taking place off camera, but it's just the nature of it. It's kind of boring to watch. So I've got all my holes drilled and the backup spar mounted, and this thing is quite solid. It wouldn't hurt to have the 2 other spaces filled with backups, but I only made 5 and I think it's totally fine the way it is. So I already measured and I'm within 2 thousandths the entire length of this thing on this surface, and so we'll measure the face from one end to the other now, and our tolerance is 10 thousandths over the full length. All right, that should do. About 2.5, 3 maybe. So we're definitely within tolerance in both the face and underneath here. So I'm gonna go double check my instructions, but I'm pretty sure the next step is to go ahead and put the scale in there and then tighten it down on these little set screws on the top. All right, that is in there. Man, that is super solid. Yeah, as long as that thing's not hit by a forklift or something, I can see how durable this will be. Obviously, putting a guard over it is not a bad idea at all, but back here and in my application, I don't think that's really necessary. Okay, so now what we're supposed to do is move the reed head back to the center. And then we've got to line up our bracket where it's going to mount up here. Okay, just checking to make sure the reed head is still parallel to the outside of the scale itself. And I think that's going to work out pretty well. So what I'm going to do is go ahead and mark the entire length of these slots. Well, not the entire length, but mark in my slots. All right, this way I don't have to do quite so much work holding on to this thing and worried about my reed head. So I know that it'll go in this spot. And everything seems to be nice and square in that spot. Okay. Really do not want to break anything this late in the game. All right. Need to get this guy. We'll go ahead and move that out of the way. And then line this guy up to my marks. And then I can decide exactly where I want the holes to be. I'm guessing just kind of halfway in between, so the top of the slot and the bottom of the main casting, just somewhere in here is probably going to be just fine. I almost screwed something up. I just went back and read the instructions and forgot a step. They want a gap between the mounting bracket and the reed head. So let's go ahead and loosen this guy, and that'll slide this whole thing back just a bit. So now we are pretty much solid on the carriage. It calls for between 30 thousandths and 180. So I've just got a gauge block here. This is 100. So now that we have a gap set, I'm going to use a feeler gauge and our set screws to take up that gap. So now we've got our set screws as little standoffs, and now I can mount these screws in there. Oops, I guess I have to use the longer ones. Last thing it says to do is to take these little brackets off, and either I missed it or it wasn't in the cross-feed one, but it says to use the wrench, use the Allen wrench as a little sliding tool. There we go. That makes it a lot easier, and then you just turn it 45 degrees and it'll pop right out. Had to mess with it a little bit last time, or on the other one. All right, easy cheesy. So now we should be good to go. Plug that cable in, and we'll have to worry about routing the cables so they're out of the way completely. Up to the readout, and then we're gonna have to figure out how to mount the readout. But yeah, this spec Z scale is finished. It's been a couple of weeks since the last segment, but I've gotten a bracket made. This is just a piece of cold rolled bar that I had sitting around. So it's screwed on to the head casting through that plate, and then just the 90 degree with fasteners over to behind this guy. And I just bought a TV mount. This is just a VESA 100 TV mounting bracket. That is, so I milled an angle on here, and then the TV bracket is screwed to that, and then the DRO reader is screwed into the TV plate. So anyway, it's not exactly in the right spot. I knew it wasn't going to be the first time in all likelihood, because I've never done this before, and I was right. I think being able to swing it out would be good. I do like about where it's at. I think another, inch backward towards the motor would be good. And the reason for that is loosening the cam blocks. There's just not enough freedom here, and I would really hate to be cranking on this and something slip and I put the back of the chuck key through the screen. That would make me very sad. But otherwise, that's about right. It's really easy to use right there and pretty safe from flying chips for the most part. Really all that's left is to make that new reed head bracket whenever I get to it, and then paint that guy whenever I get the paint out again, and then we'll be done. I do want to dig into the error compensation feature. There's a couple of instances where the backlash of the screws kind of messes with the reading, and I know it's not as accurate as it could be, so I'll have to dig into that. But otherwise, it's working out great. I've cleaned the chip pan completely when I finished the install, and so I've made a fair little pile of chips there since the readout's been installed. So it is working well and provides an excellent improvement to the machine. I did get some negative feedback on doing this, and I was kind of expecting that, but just to reiterate, I think I am improving this machine immensely. If Monarch had a tenths reading digital readout in 1952, it would have been on this machine when it left the factory. So, I am taking away from the originality of this old machine, but I'm adding an improvement that Monarch would have been thrilled to sell to their customers back then when it was new. So I am completely happy with how this has turned out, and I look forward to having a much easier go at setting shoulder lengths and bearing journal widths are going to be, all that stuff's going to be so much easier, and I've already been enjoying that. So look forward to showing more of the features of this thing in future videos, but I hope you enjoyed this install and looking at some of the aspects of installing a DRO in a big lathe. Thank you so much for watching. We'll see you soon.